All right. So we're going to start with working with the concept of domain-driven design, and we'll take like a shopping cart or website for shopping as the example. So one of the things that we'll go through is really break down like a website for shopping into its smaller parts, and then from there we'll organize those in a fashion that we can achieve reuse. And that's part of the goal of domain-driven design, is to really look at how you can pull an application apart and then start reusing pieces as part of that. So with our, if we think about a website for a store, we'll have our cart. Let me make that a little bit bigger.
Just looking for extension cords. Do we have any spare ones out here?
Nope, I'm using the extension cords.
Okay.
So we'll have our cart. We'll have like our credit card, checkout screen, or processing. What else will we have? We'll probably have some sort of like ads, like when you go to a, your checkout always has some sort of ads that are coming up, or recommendations. We'll have our recommendations as well. Some of the other parts that we'll have, we'll have a login. We'll have like the sign up. Some of the other things that we'll have, if you think about on that, shipping. So those are like some of the pieces that when we go through and look at a website, just for a simple checkout. I mean, there's more than this. You can have, tax, really gets broken down into these other smaller pieces. Now on top of this, we have our website, obviously. And what we want to do is really look at how we can organize and reuse these pieces. So out of these main pieces that we have, some of the things that are, let's say we have another team that's writing a shopping cart, or they're going to reuse the shopping cart for their piece of the application. So let's say we're a financial institution. You have your auto loans, you have your insurance, and you're able to, like Ally Bank, where you can go in and pick and choose your pieces, do your checkout, go through and pick what we want to sell. So in the larger scheme of things, for this website A, we're going to go ahead and have this information. Now if we have website B, some of the pieces that are going to be different are going to be like the ads and the recommendations. So it may have a different product line that are going to be different as part of that processing. Also, for the website B, we may not have any shipping. It may be just electronics. We're not going to have to worry about shipping as part of that process. So one of the things we want to do is look at, when you're doing domain-driven design, is really look at how, what parts are going to be reusable. In this case, the big ones that come out are going to be the login, the sign up, probably the cart. This one may be one of those that has a variant of it. So that one may be different between, like website C, and the credit card processing is probably going to be the same. We want a consistent credit card processing across all of our websites. So what this leads us to, And let me know if I get too far off the screen here, if you can still see it, or if I need to go to the other side. What we're going to do is really lay out in a hierarchy what pieces we can start reusing. So this is where if you start drawing a triangle with what's most common. So at the lowest level, we could say we'll go with credit card processing. And then on top of that, we're going to have to build up like the login and sign up. And then from there, we may have a cart. And on top of that, we're going to have more of our specific pieces for website A. So this is website A. So in this piece, we'll actually start reusing or getting specific to our application, so our ads and recommendations. So we'll go, we'll have the front end, and we'll put our ads / recommendations at this level. So what this is doing is really showing how we can build up from the lowest level the most common pieces. Now, if we have website B, let me see if I go over to this side here. I think I can be on the same screen. Website B is going to have its own front end. So we have front end for B. That will have its own ads and its own recommendations for B. The cart, in this case, we'll go ahead and reuse the cart. There's enough similarity between the two that we'll go ahead and reuse the login and sign up in the cart, and of course the credit card processing. Now below these, if we go into like the infrastructure layer, we'll actually have pieces that need to be in place at the infrastructure layer. And this would be something like, let's say all this is running on a Tomcat. And then below Tomcat, we're going to have the version of Java. And then below that, we're going to have the OS layer. Or in this case, it could be OS / Docker base image like Alpine. And this is going to be carried across over here as well. So we'll actually have these base layers, Tomcat, Java, our OS / Docker. And what this is really giving us is showing us the dependencies. So let's say we get a new version of Java that's going to be released. How is that going to affect our version of Tomcat, which is then going to affect how our credit card processing is put together, or vice versa? Let's say we have a front end that needs the latest version of Java. You know, we have a front end, we have some Java code on the servlet side. That needs Java 12, let's say, Jerry 12. And that's going to cause a ripple effect all the way down to the OS layer. So this domain-driven design really is going to go show the dependencies up and down. You know, so if the front end has a requirement, how that's going to cascade all the way down to our OS layer. You know, the version of Alpine that we install may not support the JRE 12. You know, it may be missing some of the base runtime libraries at the lowest level. So we may need to update the version of the OS or the Docker container to get the right version of Java, which will affect Tomcat and vice versa. So we can go either way in that dependency tree. But what it's really doing is laying out how our application is organized. Now, if we go into even smaller pieces, into the like the microservice world, each one of these, each one of our cart, our credit card, our ads, each one of those is going to be broken into even a smaller part. So instead of us having this kind of like this monolithic equivalent, it'll actually get broken out a little bit into more of a smaller layer. But one of the things that we have between website A and website B is up to like this level here, or actually up to cart. We're using the cart here. So we have a level of reuse for all the lower layers. So from all the way from the Docker through Java, Tomcat, all the way up to the cart, we're reusing these pieces as part of our two websites. Well, what this allows us to do is write the login, the sign up, the cart, the credit card processing once. And that's the goal of domain-driven design, is to figure out the hierarchy and really push reuse in that level. So if we actually look at another view of this, we actually end up flipping it over. So at the highest level, we'll have the OS level, then we'll have Java, Tomcat, the credit card processing. These pieces here can be broken into, depending on, we may have like a single sign-on. And that single sign-on may be one domain. The credit card processing would be its own domain. Cart would be another domain. This level I call infrastructure. The base, the Tomcat, Java, and Docker, I put that into its own type of domain. So then we have our application domain at this level. So this would be website B. And we have our single sign-on, our credit card infrastructure at that level. So it's really letting us to pick and choose where reuse is going to come into play. So now if we take this whole process and lay it out in more of like a hierarchy into like a tree view, what we're going to end up with is we'll have our infrastructure, and underneath infrastructure, we're going to have our Tomcat. We're going to have our Java, and we're going to have our Docker, we'll say Alpine. And then from there, we'll go up to another domain for credit card processing, and that'll have the processing. And then we'll have single sign-on, and underneath that we'll have login and sign up. And then we'll have our cart. That just gets cart again. And then finally we get to, so this is kind of the reusable pieces that we have designed. And then finally we get to our website. I'll go over here. So we have website. A is going to have its ads, its recommendations, and the front end. Then website B is going to have its ads, its recommendations, and its front end. Now with each one of these components that we have, we're going to have a version of it. So which version of Tomcat we're going to have, which version of Java, which version of Alpine, in those pieces, which versions of the credit card processing. Now, one of the things that we want to make sure in our domain-driven design is when we pull together this logical view of our application, we're going to go and pull the correct version of Tomcat, the correct version of Java, the correct version of Alpine, the correct version of our ads to make up our website. So this really allows us to, in the domain-driven design, really segregate out the pieces that logically fit together. We may have something underneath credit card processing that we're not using, or let's do single sign-on. So single sign-on, we may have forgot password. So we have a forgot password piece under single sign-on, but our application is not dealing with that. So we can define more things to that domain that we may not be using, but they're going to be grouped logically together. Now, one of the things that we saw in the object-oriented world was people would go ahead and create, and they would say that this object is going to be the login. I create this great, wonderful login, and somebody over here from website A uses it. And these guys over on website B say, well, that's great, except I need a slight tweak to it. And what they would do is they would go ahead and make a copy of it, and they would put the login underneath theirs. New version of that login underneath their website. Now what ends up happening is we have a copy of the login routine. And that's what was happening when first object-oriented design came out, was people would go ahead and start copying code, and then website A would say, oh, I needed a slight tweak to it. Let me go ahead and make a copy of it and change it. Instead of going and asking the single sign-on team or contributing code to the login, so we get a login version 2 and version 3. We end up with, so website A would say, oh, or website B, I need a new version. They're going to go ahead and create version 2. And then website A would say, I need a new version of that. I'm going to create version 3. Now, one of the things that we can say is website A is going to use version 3. Website B is version 2. If the changes were backward compatible, and that's where domain-driven design really comes into play, is how backward compatible are these versions? Are we breaking any of the signatures on the methods or the RESTful API calls or our RPC? If we're not breaking any of the interfaces, we can actually go ahead and start consuming the latest version. Now, I'm going to say we're going to consume version 2 of the login, and I'm going to consume version 3 of the login. Now, when this happens, what we want to be able to do is recognize who's using what, which application is consuming which version. And that's key in the domain-driven design, is to really keep track of who's using what. Because if you want to deprecate version 2 and we want to no longer support that, and we want everybody to move to version 3, we have to take a look at who's using version 2 and send them a notice saying, oh, by the way, version 3 is out. Can you guys start testing with it and start using version 3? If there's no interface changes, maybe some bug fixes, we can then have website B start consuming version 3 of the login. And once we get everybody off of version 2, we can actually make version 2 go away as part of the process. So this is critical in the domain-driven design, is to make sure things are backwards compatible. If you break the interface, version 2, let's say when we went from version 2 to version 3, we had an interface break. So version 3 is no longer, whoever's using version 2 can't just retest. They actually have to make a coding change. And that's one of those scenarios where everybody has to get up and move over in the line of things. So the website B will start having to make coding changes. They'll have to make a change to their front end, for example. They'll have a new version of the front end that has to be moved out at the same time with the version 3 of the login. So when there's a new version of the website, we have to keep track of the relationships because of that interface breakdown. And once we get everybody rolled out with their new code, along with the new version of the login, we can then go back and say we can get rid of version 2 because everybody's moved over. That's one of the challenging things when you start writing the code is to really consider the interfaces and how they're going to be. You may add support for a method before you're going to deprecate it or a call as part of that process. So what we want to do is this is going to happen on every single component that we have, whether it's going to be the cart, the password recovery, the sign up, the processing, and it'll actually even happen at the lower level. We have a new version of Java that we want to roll out. How is that going to affect everything along that process? A new version of Java is going to affect Tomcat. Do we have the right version of Tomcat, for example? Or do we have to roll out the new version? So some of these will be coupled together. Like those will be coupled. Actually, these 3 infrastructures layers can be coupled together to make sure that we have all of them rolling out at the same time. So that keeping track of all these parts and all the versions is going to be the challenging part. But we just have to recognize when we're doing our domain-driven design that we not only have these higher level categories like infrastructure, the credit card, the single sign-on, but we're going to have versions of the infrastructure and the individual pieces as part of that process. Now, as we go along and we start adding more parts to our website, we may end up having something like recommendations, for example. Recommendations may start from just be specific to the different websites. So website A may have a recommendation, website B may have a recommendation, and the developers recognize that we have enough commonality that we can, instead of being like hard-coded, we could actually make that recommendations reusable. So we can start pulling out some of the hard-codedness, put it into like a database or properties file, and we could actually move like the recommendations out of being specific to a website into its own category. So we may put recommendations now underneath the cart and make it a reusable piece and it being driven through property files or data as part of that. And when we do that, we gain more reusability now. Now we go ahead and change one thing, everybody's going to go ahead and start getting that as part of the process. And that's one of the goals is to recognize when we start copying code, because it's really easy to make a copy of stuff. It's really hard to make something reusable. I've seen very few developers that can actually create reusable code. They like to copy it, and part of it's culture. We don't have a lot of collaboration that's happening between development teams, especially if you got a development team here in the States, another development team in India, for example, as part of the process. So getting that coordination and between the different locations can be hard. This domain-driven design is really going to lay out how we can keep track of what's going where and get that collaboration in place. I've seen things. I'm working on the TechDon project which is a continuous deployment, or not continuous, but continuous delivery process that Google's heading up. And they're actually starting to break these down into different Slack channels. So they have a Slack channel just for single sign-on, so you can see what's happening with there, or for the infrastructure. You end up with a lot of Slack channels you got to keep an eye on. But the way they've really targeted is to be a group of developers is single sign-on, a group of developers is infrastructure. They will have some crossover, like you may have between credit card processing and the card team. These may be two teams, but they're logically broken out as part of that process. Any questions so far on how this is laid out?
It makes a lot of sense, and these are issues that I've dealt with before in the past too. I do have a question though. On versioning, you mentioned that you need to version each one of these components. Is
Yep.
this here the version is content-based, or it's like, for instance, in Docker, you can create a tag for a given hash-based version, but that tag is movable. Therefore, things can change under the hood, and it looks like it's the same.
Yeah.
Are you suggesting this is a content-based version so that it's immutable and you know this is the exact image or whatever, or what do you mean by versioning, or how do you see it implemented?
Yeah. So if this concept makes sense for our monolithic type of view, we'll go ahead and transition that to more of a Docker world, and we'll break it out into the Docker versioning. So if we're good here, I'm going to go ahead and clean this up a little bit, and we'll focus just on a specific part. We'll stay with our login under single sign-on. So our single sign-on with our login, this will, if we think about when we got sign up and we got password. The way I've been kind of seeing people organize, and this is kind of a limitation of Git or GitHub, is you don't have enough like directories or folders inside of GitHub. They don't allow you to create a folder, then the sub-project, so this is going to be kind of like the organizational level. So this is the org level, and then this is going to be your repo level. Now, what I've seen is to get around some of this is they'll create a organizational level, like DeployHub would be the organization, and then the repo is going to be SSO-login as an organizational structure, just so they can tag, so you can find things logically in there. What ends up happening is each one of these, like the login is going to have its own repo. It's going to be equal repo. And sign up is going to have its own repo. And from there, when we take our code, we're going to go ahead and build our Docker image for login. And in that, the way the Docker build is, we're actually going to consume a base version of that. In our repo, we're going to have our Docker file, and it'll say from Alpine at the beginning of it. And then we'll do our Java install. And that's going to be like an apt install Java. And then from there, we'll do our Tomcat. We'll say that could be just a copy. Tomcat. And then we're going to copy our application. What are we working on? Login. So we'll copy over the Tomcat code, copy over our login, like our jar file or war file, and that will create our Docker image. Now, when we do that build, we're going to get our SHA. So like AB34C, for example, will be that version of that image. Now, what we want to do is, like you said, when we tag this, we'll tag it as version 5. So that's going to be our Docker tag for matching this SHA. Now the tags, this is one of the problems that Docker has is you can move them around. Like you said, they're mutable. And one of the things that when you create your Docker image is have you ever used the label parameter in your Docker file? The label allows you to go ahead and basically put comments in there. You can do key value pairs in your label. So when we do this build, we're actually going to pull from our repo, and that's going to have a commit shot. So let's say 4.3. What we want to do is inside our Docker image, let me go over to here. So in our label, I put in there like the git commit equals, in our case, 4321. I put in other things like the git repo. So I know where we're coming from. So this would be the SSO repo for login. The build time, build date. Other things you may want to put in there, who did the last commit, user ID. So all this label stuff is really handy to put in there. And this ends up being immutable because it's part of the image itself. All this information is in there. Now what you could do is once you have your image out there, one of the tags that you want to put on there, you tag version 5. When you go and tag, you want to also put version 5 and then the git commit and 4321. I'll get it. 4321. So a lot of people are moving to not only this semantic version of versioning, but also putting the git commit on the tag as well. Or you could leave off version 5 and just go with the git commit as your tag number. One of the things that makes it easier to do is it gets a little bit hard to get used to. But once you start referring to the git commit on the tag and not doing the semantic version, the semantic version is nice because you can see the progression through time of version 4, version 5. But if you look at just the commits, it really allows you to look back to your Git repo where the source code change came from. And that really gives you the link between all the different moving pieces as part of that. So when we end up with our Docker repo and our tag, we'll say that this is SSO dash login. That's going to be the name of the Docker image. Then we'll have 4321 as the tag identifier. So instead of it being V5 or V6, we could do -V5 if we want. I've seen it both ways, but this is giving us, even though this is a mutable, it's really giving us that link to the commit. Now, if somebody does go mess with the tag, let's somebody goes and retags this to be, let's say, just latest. So they go and wipe out this tag and they rename it to latest. We can still pull this guy down and do I believe it's a Docker describe, and it'll dump out all this label information here. So because this is immutable inside the container, we can actually validate it against by doing a Docker describe and get back to the commit where it came from and ensure if somebody starts messing around with tags, we can validate against that. So it makes it very handy to start using the label information with the git commit as part of that. And also, if we want to, if we are pretty sure people aren't going to mess around with it, we could go ahead and put the commit as part of the tag information. Now, when this comes about with like a Kubernetes cluster, in the Kubernetes, you tell it which image you want to use. You can say, I want to use this git commit number instead of semantic one. Because anytime you update the image, basically tag in which image you're going to point to in Kubernetes, it's going to go bring that image down for you automatically. It'll go through its whole deployment cycle. You know, the replica controller will bring down the new one, get that one started, then roll off of the old one through the rules that you have in place. But the nice thing is when you start using the commit, like especially in a Kubernetes cluster, you can go out to your repo, search for that commit number, and you can find out the source code that's matching to it. Now, and this is going to create a version of the login. Now, if we keep on every day we make a change to login, or every couple times a week, we're going to have multiple versions of this, and those are going to stack up. We need to make sure that our application is using which version. So in this case, when we look at our application, and if these are all Docker containers, the login is going to be using 4.3.2.1. Sign up is going to be using FC3D. Credit card processing is going to use a different commit, 3.5.4.C. So each one of these is going to reference back to a commit that's in our repos. Because each one of these, credit card processing is its own repo, login, sign up, the card. Each one of those is going to have its own repo, because we want to be able to mix and match how the application is put together based on the different versions. Does that make sense?
It does. I do have one question though.
Yeah.
I've never messed with labels too much, but when you change a label when creating a Docker image, does that change the Docker hash, or is that hash really based on the file system content only? So that if you change the git commit, it actually changes the hash of the Docker image itself.
Yeah. So what's going to happen is the labels all done at the Docker build time. So when you do your build, let's say we change the commit, and we go back to here. We're going to change the commit from the login jar at this level. If you look at, depending on which build system you use, some of them you could do a Docker. Docker does a cache, a build cache, that will remember some of the previous layers, and it'll try to reuse those layers. So if Alpine hasn't changed, it'll go ahead and reuse the Alpine layer. And then it'll look to do, this is actually where it gets kind of messed up, because at this, when you do an app install, you'll get another layer. So this would be like layer 1. Can you see this on the screen?
Yep.
Okay. Then this will be layer 2.
Mm-hmm.
And then we'll get the layer 3 here for Tomcat. And then layer 4 is going to be where we actually get our first change. So when we do our next build, and we're just changing the login jar because we have a new commit at that level, layer 1, 2, and 3 will be reused. Layer 4 will be new, and then because we're creating a new, doing a new build, our label that we have as part of like the comments will get updated with our new commit number. So we'll have a new commit. That's we could have the same build date, but because we're going to create because we have a new layer coming in, we're going to end up creating a new image of from our build file. In that label, we'll have our new commit number. Now, one of the things when you go to do these, on your Docker build command, there's a build args. So in your Docker file, you can say git commit equals an environment variable name, and then you pass that in as part of your Docker build. You do build args equal build args. It's like dash build args, git commit equals, and then you can pass in from your build system the commit number. So your Docker file is only written once, and you pass in at build time the different parameters to the environment variables. But whenever we create a new layer, we're going to end up with a new SHA. So we'll end up with 33, 45, and this could be version 6 at, what did I say, 45645.
Yeah, Steve, that makes sense to me. I guess my question was more about, let's just assume all the layers stay the same. Let's say you just build the exact same thing, create the image again. The only difference is the build time for your label. That's the only factor that changes. Does the Docker image change because the label changes?
Yeah, you'll get a new SHA because of the label change. So you will end up getting a new image with a new SHA as part of that label change. I've never seen Docker where you do Docker build and then you build again even 30 seconds later, that you're going to end up with the same SHA. What ends up happening is at these lower levels, even though there's supposed to be a build cache, it always rebuilds. So I've never seen Docker where you do a build and then a couple seconds later you build again and you get the same exact image. Docker's so immutable that every time you say Docker build, you're going to get a new image SHA. Any other questions? If not, we're going to go ahead and wrap up for the day.
No, not next month. We're not
Okay.
doing this next
So next month we're actually off. We're actually going to be at DevOps World in San Francisco. So next month we're off, and then the month after we'll pick up again. I can't remember the topic off the top of my head. But we'll do the post again. Let everybody know what we have going on.
Okay.
All right. Well, thank you so much for joining today. Hopefully this gave you some insight on how domain-driven design can help you get organized and how it affects the different processes, especially when you get into microservices.